All right. So before we really talk about the different properties that go with relations, let's talk about what a relation is. A long time ago, well, depending on how old you are, usually in middle school, early high school, they talk about a relation and they skim over it really quickly. All it is a set of points. You would have heard about it like with relations and functions, and we'll talk about functions next week. But all it is a set of points. And depending on those set of points, they might have certain properties. So that's what we're going to look at. The three ways that we'll look at to represent a relation are either with a set of points, or we'll represent that set of points with a graph, or with a matrix. So let's make sure we understand how they're connected. So all three of these represent the same relation. So this point 1, 2 in the graph is represented by this arrow going from 1 to 2. So notice there's not an arrow going from 2 to 1, and there is no point 2, 1 over here. So that doesn't exist. So the direction of the arrow tells you which number comes first. And then, oops, I lost that. In the matrix, the 1, 2, this is your row and your column. So in row 1, column 2, there'll be a 1 if that pair is in your relation. So let's look at another one. Let's look at 5, 2. So because 5, 2 is in there, there should be an arrow going from 5 to 2. There is. Good. And in row 5, column 2, so row 5, column 2, there is a 1. Are you guys okay with the different representations? Okay, so I really want to emphasize that I don't care which one of these representations makes the most sense to you, but it's important to go between them. So in the homework, you might be given asked questions about a graph. If it makes more sense to you to write the graph as a set of ordered pairs, do it. So whatever representation works for you, just convert to that representation first. All right, now let's go into some properties. So there's kind of, say, three groups of properties. The first is it reflexive, irreflexive, or neither? So one of the common mistakes is that people think it's either reflexive or irreflexive. And it doesn't have to be. It doesn't have to be either one. So it's really a choice of three. Is it reflexive, irreflexive, or neither? So let's start with what reflexive means. Reflexive means that every possible pair that is a repeated, this AA, is in R. So what this first thing means is that AA is in R for all the A's in A. So I guess maybe I should write down what our A is. A is where we get our elements that are in my pairs. So 1, 2, that's supposed to be a 2. 2, that's still not a 2. Okay, 3 and a 4. So because A consists of 1, 2, 3, 4, 1, 1, 2, 2, 3, 3, and 4, 4 have to be in there. So all 4 have to be in there in order to be reflexive. So I can just look at my set of pairs here and see that 1, 1 is not in there, so I can stop. It is not reflexive because 1, 1 is not in there. So you can look at the pairs to do that, or if we look at the graph, you can tell a graph is reflexive if every vertex has a loop. So only 4 has a loop, so that tells me it only has 4, 4. So again, it's not reflexive because it doesn't have the others. And then if you're looking at the matrix, the diagonal is this portion. If along the diagonal, every value on the diagonal is, I don't know why I missed 5 earlier. Please forgive me. There should be a 5 here, and there should be a 5, 5. every element along the diagonal has to have a 1. That would mean all of those are in there. So I feel like I messed with you guys because I'd missed up the 5, 5. Do you feel like you're okay? Okay. Alright, so that's, again, to be reflexive means every one of those has to be in there. In order to be irreflexive, all of them cannot be in there. So it's saying for every AA not in R, all of them cannot be in R. So none of 1, 1, 2, 2, 3, 3, 4, 4, or 5, 5 can be in there. So this has 4, 4. So it is not irreflexive. If you're looking at the graph, you can tell that it is not irreflexive, again, because of this loop. So if it has any loop, it cannot be irreflexive. And looking on the diagonal, if it has to be all zeros to be irreflexive. Alright, so this relation that we're looking at is neither. It's not reflexive and it's not irreflexive. Alright, the next kind of grouping of properties are symmetric, asymmetric, and antisymmetric. So we'll start with symmetric. And symmetric means if, the formal definition is if AB, so for any A and B, if AB is in your relation, that means BA has to also be in your relation. So for example, if 1, 2 was in my relation, then 2, 1 would also have to be in my relation. So 1, 2 is in my relation, but notice 2, 1 is not, so it's not symmetric. If we're looking at the graph, it means that every edge has to have a double arrow. So this 1, 2, 2, 1, that one does not. Notice that, a lot of them do not. So there's a lot of reasons. There's lots of examples to show that it's not symmetric. If you're looking at the matrix would have to be symmetric. And what symmetric means, informally, what it means is if I draw a line on my diagonal, so think of that as a piece of paper, and if I folded it along that diagonal, everything has to match up. So like these ones right here, they match up. But this 1 and 0, they don't match. This 1 and this 0 don't match up. So again, there's lots of reasons why that don't match up to make it not symmetric. Alright, so to be asymmetric means if AB is in R, then the reverse is not. So think about that last one, if 1, 2 is in my relation, then 2, 1 is not in my relation. And that is true. So for that one example, this is true, but that does not show that it is asymmetric. It just doesn't show it's not. So the key for all of these properties is if you cannot show a property fails, then it has the property. Alright, so I'm going to go through some more because this one works. That point works. So it doesn't help me show it's not. So let's try, so if 1, 3 is in R, then 3, 1 also has to be in R. Is 3, 1, 3, 1 cannot be in R. That works. 1, 4 also works. So let's see, that works, that works, that works. Notice this 2, 3, and 3, 2. They're reversed order and they're both there. So that tells me it's not asymmetric. In terms of looking at the graph, no edge has a double arrow. So I have a double arrow. But also notice it has to also have no loops. So the double arrow from 2 to 3 shows it's not asymmetric, but so does this loop. So either one of those shows it's not. And then if you're looking at the matrix, so it says the ones on the off diagonal, so there's my diagonal. The ones on the off diagonal have to correspond to the 0. So this one corresponds to a 0. Oh, that's good. But they all have to. This one corresponds to a 0. Good. And then this one corresponds to that 0. Good. But notice, use a different color for a second. This one matches with this one when you fold it, so that's why it doesn't work. And then also you have to have zeros on the diagonal, so this is the loop, this corresponds to the loop, so both those are reasons. So how is asymmetric? Is that one okay? All right. All right, antisymmetric and transitive, the two kind of last ones, are the ones that tend to cause the most problems. So maybe we'll spend more time on these two. So it's antisymmetric if both AB and BA are in the relation. So you have to start off with that. So you have to have the kind of reverse order. You have to both be in R, but that means that A is equal to B. So the only pairs that we have, so let's see, 2, 3 is in R, and 3, 2 is in R. That would have to imply that 2 equals 3. It does not. So that shows it is not antisymmetric. If you're looking at the graph, no edge has a double arrow, but you can have a loop. So loops are okay, but no double arrows. So this is what causes the problem. And then same as before, the ones on the off diagonal. So these two match up and they can't. So that's the reason why they're. So this is very, very similar to asymmetric. The only difference is that loops, you can have loops or you can have repeated pairs. So you can have like 4, 4 and be antisymmetric, but you cannot be asymmetric. After I go through transitive, I want to go through an example and go through all the properties with them, just to give you another one. So for transitive is if A, B is in R and BC, then AC must be in R. So notice these middle values have to be the same. So let's see, if I have 1, 2, so think of this as my A and my B, then I need a B and a C. So this has to start with a 2. The only pair I have that starts with a 2 is a 3. So I have both of those. That has to imply that 1, 3 is in R. It is. So all that does is show me that it doesn't fail yet. So let's try another one. Let's try 1, 3. So this has to start with a 3. And the only point I have that starts with a 3 is 3, 2. And that would imply that 1, 2, and it is. So great. Okay, I have evidence to suggest it might be transitive. Let's look at 1, 4. If I do 1, 4 is in my relation, I need to start the next one with a 4. The only one I have that starts with a 4 is 4, 4. Now when I take those outer pieces, it has to be that 1, 4 is in relation, and it is. So you don't really ever have to check with the repeated pairs like 4, 4, because those will always work. Let's try 2, 3. So I'm just trying to go in order. So if I have 2, 3, and I have 3, 2. That would imply that 2, 2 is in my set, and 2, 2 is not. So it is not transitive. Again, you just find one that does not work, it means it's not transitive. The only, let me just repeat this, the only way to show something, a property does hold, is to go through all the possibilities and show that it works for all of them. Not transitive. All right, any questions before I do another example? All right, I'm going to go to a blank sheet. So sometimes people get really confused when the relation is defined by one point. So let's let 4, 4 be the only point in my relation. And let's suppose that A that I started with is just 1, 2, 3, 4. So first property, is R reflexive? What do you guys think? Okay, why are you saying yes, Tyler? Why do you say no? Good. So in order to be reflexive, it would have to contain 1, 1, 2, 2, 3, 3, and 4, 4. It has to contain all of them. It does not contain all of them, so no. And you could say because 1, 1 is not in R. So second one, is R irreflexive? What do you guys think? Good. Great job, guys. So no, you can say because 4, 4 is in R. So to be irreflexive, none of 1, 1, 2, 2, 3, 3, 4, 4 can be in R. All right, so the third property, is R symmetric? So symmetric meant if A, B is in the relation, then BA is also in the relation. So what do you think about this one? Is it symmetric? Great. So when you're, good job guys. So when you're justifying these in the homework, you should, anytime you have a no, it should be a quick reason why, and you don't have to justify the yes. It's just justifying why a property does not hold. Because showing something does hold is a lot harder. But it's yes because the only point in R is 4, 4. And if you reverse the order of that, you get 4, 4, so you're still in R. So yes, great. Is R asymmetric? What about this one? Great. Can you be both symmetric and asymmetric? Oh, great, Tyler. You just... Great. So if it is symmetric, it's automatically not asymmetric. What about anti-symmetric. So let me just remind you what this is. It's if AB and BA are in R, then A equals B. Great, Tyler. So what are you saying? A equals A? Yes, awesome. So again, in this case, the only point we can have for A and B is 4 and 4. So when you reverse the order, both 4, 4 and 4, 4 are in the relation, and 4 equals 4, so yes. Again, another common mistake is that people think that if it's symmetric, it can't be anti-symmetric, but clearly it can. 6 is R transitive? What do you guys think? All right, this is why I did this example. That is the most common thing to say, that you're going to say no because you can't have a comparison. So, you have if for 4, I guess technically I could, and for something, you don't really have a C. Can you prove it wrong? Can you give me an example to show it's not transitive? Like, can you give me 2 pairs? So, can you give me 2 pairs that show it's not transitive? So 4, 4, and 4, 4 are in the set. And if I take the first and third, first and third, 4, 4 is still in my set. So if you cannot find an example to show it's not transitive, it is transitive. So the only way to show it's not transitive is to give an example. So anytime you have just one point, it is always transitive because you can't show it's not. Yeah, that's very common on that first question with the 1 point. And anytime you have 1 point, they often just say it's transitive by default because you can't even satisfy the if part because you can't get 2 points. So if you can't satisfy the if, there is no conclusion. It's kind of that weird thing about like if the first part is a false, that doesn't matter what you say afterwards. So I feel like I keep saying it. It's transitive by default because you cannot show it's not. So good. I just want to make sure we go through an example like this one because I know it causes a lot of problems.